In this video, we are going to be looking at the Bernoulli's equation. The Bernoulli's equation is simply a fundamental principle in fluid dynamics that relate the pressure in motion. The word fluid simply means water, and when we say motion, this simply means change of state or position. Notice that in physics, velocity is being denoted by capital letter V, and the pressure is being denoted by capital letter P. Notice that Bernoulli's equation is given by P1 plus a half rho V1 to the power of 2 plus rho GH1, which is equals to P2 plus a half plus rho V2 to the power of 2 plus rho GH to the power of 2. What we have in this formula is combination. We have the combination of G, V, P, H, and rho. But at the same time, you should notice that we have V1 and we also have V2. We have P1 and we also have P2. We have H1 and we also have H2. But for the density, that is rho, we only have 1. Notice that P1 and P2 are the pressure of the cross-section of P and Q. That is the distance which you have between P and Q here. Here we have Q. V1 and V2 are the velocities at the cross-section of the same P1 and Q1. What about the density, which is this? The density, this simply identifies the density of the fluid. And the G is the acceleration due to gravity, which is approximately 9.81 meters per second. What about the H1 and H2? These are the heights of the cross-section of the same P and Q. Now that from the equation, we are assuming, notice that from this equation, we are assuming of everything. That is the pressure, the kinetic energy, and the potential energy of the cross-section is equal to the pressure, kinetic energy, and the potential energy at another cross-sectional area. What this formula is trying to explain is that when we have the pressure and the velocity of the fluid at two different points, this is P1 and here we have Q1. What will happen? If the velocity increases, notice that if our velocity, if the velocity, that is V2, here we have V2 and here we have V1, if the velocity increases against V1, the only thing that will happen is the pressure of P2 will be less than P1. What if the height increases? The pressure will decrease. If this height increases, the pressure will decrease. Meaning that if we have H2 and it should be greater than H1, what will happen? P2 will be less than P1. So let's look at some few problems and see if we can solve it together. Let's say you're given this kind of problem which says a water pipe has a diameter of 0.1 meters at point P. Here we have P. Remember, let's say here we have P and here we have Q. And in the case of Q, it's 0.5 meter at point Q, which is 5 meters height. Let's say here the height, let's say we have 5 meters. If the pressure at P is 100,000 pascals and the velocity is 5 meters per second. Here, notice that we're talking about Q, right? Here we are given the velocity to be 5 meters per second, and the pressure here we are given to be 100,000. Pressure at P, right? Find the pressure and the velocity at Q. So the pressure that is at Q, right? The pressure is unknown and the velocity also is unknown. And we are asked to assume the density of the water is 1,000 kilogram per meter cube. In this case, our density is going to be 1,000 kilogram per meter cube. Okay, how can we solve this problem? First thing we need to do is to get our data out. Let's say, remember, we are giving P1 to be 100,000 Pascal. And we are giving V1 to be 5 meters per second. What about the H1? Remember, we are not giving anything at the H1, but in the case of the H2, we are giving 5 meters per second, meaning that our H1 is simply going to be 0. What about the H2? In this case, the H2 is 5 meters per second. 5 meters per second. What about the density? The density is 1,000 kilogram per meter cube. What about the diameter? We have two diameters. The D1 is 0.1 meter, and we're given the second diameter to be 0.05 meters. So how can we solve this problem? In order for us to solve this problem, the first thing we need to do is to find the area of the pipe starting from the P up to the Q. In this case, since we are asked to find the area, the formula is going to be A1 and A2. In this case, the A1 is going to be pi D1 to the power of 2. What about the A2? The A2 is simply going to be pi D2 to the power of 2. Starting with the first one, which is the diameter of the first problem, which is for the P. A1 is simply going to be pi. What is the value of D1? Notice that the value of D1 is given to be 0.1 meter. This is simply going to be, we're going to multiply the value of pi by 0.1 meter square. In this case, our A1 is going to be 0.00314 with the square root in meter. What about the A2? In this case, notice that A2 is going to be pi D2 to the power of 2, which is going to be 0.05 to the power of 2. And if you punch in your calculator, your answer is going to be 0.000785 to the power of 2. Remember, our unit is going to be in meter, and this is going to be in meter also. So, notice that, let's put it this way. The area A1, what is the value of A1, which we find is 0.00314 to the power of 2 in meter. What about the A2? A2 is going to be 0.000785 square in meter. So next thing we need to do is to use the continuity equation to find the velocity at point Q. Since we have the velocity at point P, which we said is 5 meters per second, remain to find the velocity at V2. Okay, let's say V2 is unknown. How can we solve this problem? Making V2 to be the subject of the formula is simply going to be V1 into bracket of A1 divided by A2. Our V2 is simply going to be, what is the value of V1, which is the first velocity, is 5. This is going to be 0.00314. We are going to divide that by 0.00, it's going to be 3.0785. If we divide both sides, our V2 is going to be 5 into bracket of 4. If you multiply 5 by 4, our velocity at Q is simply going to be 20 meters per second. So now at this point, we can finally use the Bernoulli'S equation to find the pressure at Q. Here we have the velocity at Q is simply going to be 20 meters per second. What about the pressure at Q, which is still unknown? Okay, let's put down our equation for us to find the pressure, because the pressure is unknown. So our equation, that's the Bernoulli'S equation, is simply going to be P1 plus a half rho V1 to the power of 2 plus rho GH1, which is simply going to be P2 plus a half rho V2 to the power of 2 plus rho GH to the power of 2. So we can insert our value right at this point. In this case, this P1 is the pressure, which is simply going to be 100,000. 100, 1, 2, 3. Plus a half. What is the density? Density is 1,000 into velocity. First velocity is going to be 5 to the power of 2 plus the pressure, which is 1,000 into bracket of, that's density, What is G, which is gravity due to acceleration, which is going to be 9.81 in meter per second multiplied by 0, equal to the right hand side right now. What is P2? P2 is unknown, is going to be P2 plus still a half into bracket of 1,000 into 20 to the power of 2. We are going to plus that by the same 1,000, multiply it by 9.81, multiply that by 0. So what are you going to do at this point? You can start with the initial pressure. The initial pressure at point P is simply going to be 100,000 Pascal. We are going to subtract the change in pressure due to the increase in velocity. That is from 5 meter per second to 20 meter per second. And our final answer is simply going to be 50,000 pascals. So the last thing you need to do at this point is to subtract the change in pressure due to the increase in height. Due to the increase in height, these are some steps. Let's say this is the first step, second. Due to the increase in height, right? That is from 0 to 5 meter per second. And your answer is simply going to be negative 49,050 in pascals. So at this point, what you need to do is to add these two values. So here, that's the first one, that's this. We are going to add 100,000 minus the 3,000 minus 49,050. And your final answer is simply going to be 950. Therefore, we can finally conclude and say our P2 pressure at Q is simply going to be 950 Pascal. So notice that the pressure, so this is it for this problem, but I need you to understand that the pressure decreases as the water flows faster. This happened due to the increase in velocity. Also, the pressure also decreases as the water goes up due to the increase in height. So this is it for this problem. I hope you find it helpful. Feel free to like, share, and subscribe. See you next time. Thank you for watching. In this video,